Hey guys, Mr. G here, and today we get to talk about multipliers and fun with the MPC and the MPS. Special thanks to all this stuff who this is ripped from. Appreciate you. All right. So what all of this is focused on is something called disposable income. Disposable income is effectively the money that you actually make. It's the money that you receive from your paycheck. When talking about disposable income in your personal life, it might be the money that you have after your bills, but for our intents and purposes, it is your paycheck, right? Your after-tax income. So once the government's taken away what they need for Social Security or whatever else it might be, that is what we're looking at here. Now, this income then is going to be divided into two different things. The MPC, which is the marginal propensity to consume, and the MPS. Right now we'll talk about the MPC though. So what the MPC is, I realize what it says right here, but what the MPC is the amount of every dollar that you are getting that you are spending. All right, so for every dollar, you're spending 80 cents of it, or for every dollar, you're spending 90 cents of it, whatever it is. Meaning that overall, what it's going to look like is you're spending 80, 90, 95% of your disposable income there. Now, what we're looking at here, MPC being the change in consumption divided by the change in disposable income, which is pretty much just saying it's a change in how much you are spending divided by the change in how much you're actually making. What this will end up looking like, there you go. So change in C over change in DI. For this part, we're not really going to use it too terribly much. Calculating MPC is usually not like this. A lot of times it'll just be not even the change, but just your consumption over your income, something like that. So it could be that you're making $100,000 for your disposable income, right? And your consumption is $90,000. So it'd be 90,000 divided by 100,000, giving you 0.9, something along those lines. But it is good to know nonetheless. On the other side of this, then, we have our marginal propensity to save. And it is the fraction of any change in disposable income that is saved. So again, whereas our MPC is how much we're spending, our MPS then is how much we are saving. So there's this one, there is kind of another way around it, right? So it could be the amount that you're saving divided by the your disposable income, right? So going back to that 100,000, if we were spending 90,000 of it, that means we're saving 10,000 of it. So it'd be 10,000 divided by 100,000, giving you 0.1. Or the way around it is MPC plus MPS is always going to be equal to 1, right? Because it's the amount of every $1 that you're spending or saving. If we're looking at it overall, the 1 represents 100%, and you can't make/spend more than 100% of your what you're making. So it looks like that. So anyways, what I mean to say is that the shortcut for it could be then is the 1 minus the MPC. So in this case, it'd be 1 minus 0.9, giving us 0.1. So it's just another trick to figure this out here. And then, change in S over change in DI. All right. Marginal propensities then. So again, MPC plus MPS is always going to equal 1. MPC will be 1 minus MPS, MPS will be 1 minus MPC. We're operating under the assumption that there's only two things that you can do with your disposable income: consume it or save it. That's it, nothing else. Again, consuming it means you are spending it on something. The actual MPC in our country is somewhere from 0.9 to 0.95. As recessions begin to happen, MPC tends to go down and MPC tends to go up. As there's negative expectations for the future, MPC tends to go down, MPS tends to go up. As there's positive expectations, as times are going well, MPC tends to be higher, and MPS tends to be lower. It ends up depending. So the spending multiplier effect. This is why we need to see this, or understand what this is. So an initial change in spending ends up causing a much larger change in aggregate demand than the initial change itself. Now, the two important ones for this are going to be government spending and investment spending. Primarily government spending, however, is going to be the big one with this multiplier here. So the multiplier then is going to be the change in aggregate demand divided by the change in spending. Though this is kind of a backwards approach to it, and I really hope the correct approach is going to be here. But this is looking at just the whatever the total impact is in GDP divided by the initial change in one of these. So let's see here. So why does this happen? The reason why it ends up happening is because when you spend money, that money ends up being, it ends up going somewhere else, right? So for example, you have $100,000 that you are making, well, $100,000 that gets spent, to simplify this, right? So you take your $100,000 and you spend it. Say it is that you buy a new tractor, something like that, right? Now, our marginal propensity to consume is 0.9, right? Meaning that when you spend that $100,000, the person that's now receiving that is going to spend 90% of it, and they're going to save 10% of it. Okay, so you already spent your 100,000. Now they're going to go spend 90,000, right? See what I'm getting at? And then the business gets that 90,000. They're going to take 10%, and they're going to go and spend it. Okay, so that 90,000, then they're going to save 9,000, and they're going to go and spend 81,000. Okay, and then that just keeps going on and on and on and on until we're left with fractions of pennies. And ultimately, what this means then is that changes in specific types of spending, again, government spending being the big one and investment spending to a lesser extent, ends up having a much larger impact than what initially would appear. So here's a good example. If the government increases its defense spending by $1 billion, then what's going to end up happening is that they're going to end up, these contractors that they hire and pay, and the resources that they buy for, well, whatever defense stuff they do, is going to end up getting redistributed back into the economy, right? Because what we're going to see is the defense contractors that they're now employing now have a paycheck. With those paychecks, they're going to go and pay their rent. They're going to buy food. They're going to buy whatever they want as they're buying the resources that they need. Those companies are then going to use that money to pay their workers and buy things that they need, right? And so on and so forth until, again, you're left with nothing. So it'll end up being by far more than the original $1 billion. Now, here we go. This is the actual spending multiplier, and this is the very relevant term here, or the relevant formula is this. There's any one thing to take away from this, it's going to be this right here. So, the spending multiplier can be calculated from the MPC or the MPS. Either one works. And it's going to be 1 divided by 1 minus MPC, or just more simply, 1 divided by MPS. I like writing it as 1 divided by MPS because 1 minus MPC is quite literally the formula for MPS. So, yeah, that's what I prefer doing. You could do it either way, though, as long as you end up getting the right number. So, that said, multipliers are in a positive thing. They end up positively multiplying the impact on GDP when there's an increase in spending. However, it can end up having a negative impact too if there ends up being a decrease, as we'll come to see. Tax multiplier then is going to be similar but also different. Something to note with this, like it says right here, it's going to be negative, so it'll be negative MPC divided by the MPS. Or negative MPC divided, or sorry, negative MPC divided by 1 over MPC. But note, something different with this, right? What's different? Yeah, it's 1 on the spending, whereas with the tax, it's MPC that is on the top. So that's a big deal because the idea is, right, is that when we're talking about changing taxes, the initial change itself doesn't end up getting included, right? It doesn't. So you're multiplying it effectively one less time when we end up doing the formulas here, right? Because I mean, yeah, again, GDP only calculates the final value of goods and services in an economy, whereas with taxes, it doesn't reflect that. So the tax multiplier will be negative. Now, if there's a tax cut, the multiplier will be positive, okay? Because now there's more money in the circular flow of the economy or in the economy in general. So if there's taxes, it'll end up having a negative impact on GDP. If there's a tax cut, it'll end up having a positive impact on GDP. So we get to do some practice. So for example here, assume U.S. citizens spend 90 cents of every extra dollar they earn. Further assume that the real interest rate decreases, causing a $50 billion increase in gross private investment. Calculate the effect of a $50 billion increase on investment, or sorry, a $50 billion increase in investment on U.S. aggregate demand. So, step 1 is to calculate the marginal propensity to save and the marginal propensity to consume. So that said, again, for calculating this, to get it down officially, all right, to calculate the MPC, you're dividing that 90 cents by the dollar there, all right, meaning that it'd be 90 divided by 100, giving you 0.9. And on the other hand of it, if they're spending 90 cents, that means the other 10 cents is being saved. So that'd be 10 divided by 100, giving you 0.1. Or again, what you can do once you've figured out 1 is you then go to do 1 minus 0.9, 1 minus 0.1, and figuring out the other. So that said, and this is where we start seeing the changes too. I don't focus on that personally, but you can very much do it. But anyways, yeah, so it's the 0.9 divided by 1, or 90 divided by 100, however it is you want to look at it. And then MPC, there you go, you use the the minus there from the 1 to get the 0.1. Either way, we end up getting to the right numbers. So, next step, you need to determine which multiplier to use. In this case, we are in fact using the spending multiplier, right? There's only the 2 multipliers, spending and tax. This isn't talking about taxes. This is talking about businesses investing in capital, meaning that we end up using the spending multiplier, which is our 1 minus MPC divided by MPS. As you see here, you use a spending multiplier, and then you calculate the spending and or tax multiplier. Let's see if it actually runs through it here. It didn't run through it as well as I hoped it would. But anyways, I think I might have stated it wrong earlier. Just I apologize. But anyways, so it's 1 divided by the MPS. I think I said 1 minus MPC divided by the MPS, which would be MPS divided by MPS, which is completely wrong. So ignore that, I swear. But anyways, it's just 1 divided by 1 minus MPC or MPS. So in this case, then, it is 1 divided by 0.1, giving us 10. Meaning that since this is a multiplier, what are we then going to do? That's right, we're going to multiply it. So what you then do is should say right here, calculate the change in aggregate demand. So you're going to take that multiplier of 10, and you're going to take that initial change, right? So we're at 50 billion times 10, giving us a $500 billion change in aggregate demand. Because again, what's going to happen is that these businesses are going to take their $50 billion and they're going to buy new tractors or whatever it is, and then the tractor companies are going to pay their workers and they're going to buy the parts for the tractors, and in turn then all the natural resource companies that provide the rubber or the metal or whatever it is, they're going to pay their workers, and then those workers and all the workers are going to pay their rent and they're going to buy food and so on and so forth. So what we'll end up with then is that multiplier having a huge impact on all of this. Another example then, we're going to have with, looks like Germany here. Believe that's the euro. Could be wrong. Anyways, so assume Germany raises taxes on its citizens by 200 billion euros. Furthermore, assume that they save 25% of their disposable income. Calculate the effect the 200 billion change in taxes on the German economy. Sorry. So step one, calculate the MPC and MPS. So they're saving 25% of their disposable income, meaning that 25% of every dollar is being saved. Okay. So you could do this the long way here. It would be 0.25 divided by, well, I mean, be 25 divided by 100, giving you 0.25. So yeah, 0.25. And then if it's 1 minus 0.25, that gives you 0.75 for the MPC. So let's get that on here. There you go. Now, determine which multiplier to use, whether it's negative or positive. In this case, reading through the question, it says that they're raising taxes. So first off, we're going to use the tax multiplier. And since they're raising taxes, and this isn't a tax cut, it's going to end up being a negative. So negative tax multiplier. So you use a tax multiplier, which this time I promise it is negative MPC divided by MPS. In this case, then it'd be negative 0.75 divided by 0.25, giving you negative 3. And again, this is where it's important to distinguish the tax and the spending multiplier. Again, if this was 1 divided by 0.25, that'd be, well, negative 4. But again, the initial change doesn't have any impact on GDP. It's just the fallout of it then that ends up being the bigger deal. So when we're talking about all of this then, really big idea, you could say, is that the spending multiplier ends up having a larger impact than the tax multiplier because it's the initial change that does something and not just the after effects there. So anyways, we have our multiplier, and again, what is it that you do with the multiplier? That's right, you multiply with it. So you take your 200 billion euros, and then you multiply that by negative 3, and then you get negative 600 billion. There you go. So you get a negative $600 billion impact, or negative $600 billion change with our delta there in aggregate demand. Wow, lots of examples in this one. That is a delight. Let me just, okay, get a new sheet of paper here. All right, so assume the Japanese spend 4/5 of their disposable income. Furthermore, assume that the Japanese government increases its spending by $50 trillion. 50 trillion yen, that looks like. In order to maintain a balanced budget, they simultaneously increase taxes by 50 trillion. Calculate the effect of a $50 trillion change in government spending and $50 trillion change in taxes on Japanese aggregate demand. So this is something we'll see from time to time. And this is ultimately known as the balanced budget idea, which kind of questionable sometimes, but we'll see where this gets us. So let's get back over here. So calculate the MPC and MPS. So we know that the Japanese are spending 4/5 of their disposable income. All right, so if you do 4 divided by 5, what does that give you? That's right, it gives you 0.8. So our MPC is 0.8, 1 minus 0.8 is 0.2, so our MPS then is 0.2. Now, that said, we have that calculated. All right, we need to determine which multiplier to use and whether it's a positive or negative. We have two different things going on here. All right, we have our government spending increasing by $50 trillion. So we would have a positive spending. And then furthermore, we have a $50 trillion increase in taxes to balance this out. What we're going to see, though, it doesn't 100% balance, and this is kind of why it ends up working. So we have an increase in taxes, meaning we have a negative tax multiplier. So, yep, we got both from there. So then we calculate the spending and tax multipliers. So for our spending, again, let's get it out here. It's 1 divided by our MPS. So it'd be 1 divided by 0.2, ultimately giving us 5. So it's a positive plus 5 multiplier there, positive 5. And then for our tax, right, it's going to be our MPC divided by our MPS Get that up there. All right, or negative MPC divided by MPS, giving us -4. All right, so -4. So this, again, like I said, you probably saw where this was going, right? Because again, the spending multiplier has a larger impact than the tax multiplier. Meaning what's going to happen is when we calculate this, it's not just going to be a no-sum game. All right. So what we see here then is that we take our 5, we multiply it by that 50 trillion, giving us 250 trillion. All right. And then we take our 50 trillion and we multiply it by our -4 from the taxes. That's a -200 trillion. We add them together. All right. And then we get 50 trillion. So what this effect is going to have then is there will be a positive impact on GDP of $50 trillion. Add $50 trillion to the GDP, because again, the spending multiplier is much stronger than the tax multiplier by a magnitude of 1, because again, the initial change is included with all of it. But for the most part, a lot of times they end up having the same impact. I can't speak. The balanced budget multiplier. So this is something we're going to kind of gloss through. We don't need to talk a whole lot about it, but it's kind of simplifying that question a little bit, even though it kind of looks like a headache. So it'll be 1 divided by the MPS, which is our spending multiplier, plus the tax multiplier, equals 1 minus MPC divided by MPS. That's one of the ones that I mentioned earlier, which equals MPS divided by MPS, which ends up equaling 1. All right, so that's the theory behind it. It's just that it's 1. That's kind of the joke. It's always going to be 1. Yeah, see, I mean, I'm right here. Let me move me out of the way right here so you can see it. Yeah, so the balanced budget multiplier is always 1. Meaning that $50 trillion that we saw, if they're going to increase taxes to balance it out, it's always going to be the same as the change in spending there, or the change that we're going to see to try to balance out the taxes. It's just how it works. And that's why we skip over it, because it's not the biggest deal. So that's everything for our multipliers, MPC, MPS. Feel free to let me know if you have any questions, and that is all for today.